had a transistor circuit earlier, we had current here causing current here, and no emitter resistor here. Basically, the emitter's stuck on ground. If you change this transistor out, the beta of the transistor that you're changing it out to is going to determine how much current is in the collector. So you could have 3 different transistors here and 3 different VCEs, which is not a good thing. So they came up with another circuit very similar to this one. They put a emitter resistor in. So we have RC, RE, and RB. Okay, the way this works is that if you have more IC, you have more, yields more IE, which the voltage drop increases. Voltage at the base increases, which means the voltage drop here on RB, VRB, actually decreases. And if VRB decreases, then less current. And beta DC times IB determines the emitter current. Okay. Now, if we change this transistor out, well, let's say we had a beta of 100 first, and then we went to a beta of 300. If we went to a beta of 300, that means less current here would cause more current flow here. If we swap this transistor out with a beta of 300, then we would have more collector current here. Voltage here would increase. Voltage here would increase. We'd have a decrease in voltage drop across RB, so it means less current. And then we would have less emitter current. So this feedback design was pretty popular to start out with, and I've seen it in circuits recently, although it's not as stable as the voltage divider bias circuit, because it is semi-dependent on beta DC. This one is really dependent. Okay. New circuit, VCC hooked up to here. We have let's say, less beta transistor and more transistor. So if we've replaced this circuit, let's have a look and see how this circuit works. We have current flow this way here, and we have current flow this way. The VCE is what sets up the voltage drop across here. So the voltage drop here is VCE minus plus 0.7 volts. No, it's just VCE. the VCE minus 0.7 volts is the voltage drop across this guy. If we take this transistor out and replace it with one with a higher beta, that means that less current here will cause more current here, and more current here will increase the voltage here, and actually VC will go down and VCE will also go down. And if VCE goes down, then the voltage drop also goes down, equals less current IB, and that equals less IC. So this one has some self-regulating properties also.